Hello everyone. In this video, we shall discuss the concept of constructors and distructors which we use in object-oriented programming. The video is taking a platform of C++ to describe the concept of constructors and destructors. Now, let's see what are constructors. A constructor is a special member function whose task is to initialize the objects of its class. So now let us go back to the concept of object-oriented programming. So let us look into the class. Class contains two very important activities. One is the attributes and another one the methods, which are otherwise called member functions. So now here a constructor is also a member function which we define inside the class. But it is a special member function. That means constructor is not like an ordinary member function which we define in the class. It's a special member function. So why is it special? It is special because the purpose of the constructor is to initialize the object of its class. So normally when we define an object, definitely an object will be an instance of a class. So we just mention the type of the class with the possible attributes, their visibility, and then the possible member functions. And anywhere in the main function, we may define an object. But in all these cases, we never initialize the object. So here, if at all we want to initialize the object, when an object is created, we have to use a constructor. So the purpose of the constructor is to create an object and initialize the object whenever an object is created. And it is also special because the name of the constructor must and should be the name of the class itself. Normally, when we define any member function like get data, display, calculate, sum, so we may give any name to the member function within the class. But if at all we want to call a constructor or if at all we want to define a constructor inside the class, there is a rule. The rule says the constructor must and should have the name of the class itself. And the constructor is invoked whenever an object of this associated class is created. Now here once again, when we go for any member function, let me give an example. Get data. If you write a get data function inside the class, then you may have to write specifically the in the main function to invoke the get data member function. For example, if you create a class called item with the two attributes, say number as well as cost, then if you want to use a get data function, then you mention a member function called get data. Then in the main function, if you declare an object as say x, then if you want to invoke the get data function, you may have to specifically mention x dot get data. Then only the member function will be executing. But in case of constructor, it is not so. So in case of constructor, whenever an object is created, the constructor is automatically invoked and it will assign a value or which is initializing a value for the object which is created. That's why it is called a constructor because it constructs the value of data members of that class. The purpose of the constructor is to construct the values of the data members of the class. Now let's see how the syntax of the constructor. See, as we see here, we have created a class called integer. So there is a class called integer with the two attributes m and n of int type int. They are under private. So in the public, we have called a function. What is it? Integer. What is it actually? It is a constructor. Why do we call it a constructor? Because the rule here says constructor is a special function because its name is a name of the class itself. So here it's proven. We have called a class called integer. Inside the integer, under the public, we called a function called integer with the argument as void. So an member function integer within a class called integer, both are the same, is nothing but a constructor. So here, this is how we declare a constructor. This is how we define a constructor. So in order to define a constructor, we can go outside class name, scope resolution operator, name of the constructor with the parameter. Here there is no parameter. Since there is no parameter, we mention void over here. So here m is assigned to 0, n is assigned to 0. So the purpose of this particular slide is to mention that how are we going to declare a constructor inside the class. The rule is the name of the class and name of the constructor must be the same. And outside, when we invoke, it should be the name of the class, scope resolution operator, name of the constructor, which we normally mention to define the constructor. And here, one more very important point to note that any constructor, whenever you define inside a, you declare or you define, both are possible. Inside a class, it should be done in public. You cannot do it in private. So it should be done in public. So when a class contains n constructor like the one defined above, it is guaranteed that an object created by the class will be initialized automatically. So here, whenever you create any object of class integer, the attributes are automatically initialized to 0 because the constructor is going to initialize the value. So according to this, you mentioned a object called int1. So int1 has two attributes, int1 dot m and int1 dot n. So what is the value of int1 dot m? It is 0. Int1 dot n, that is also 0 because they are initialized to 0 through a constructor which is called integer. So now, what are the special characteristics of the constructor? Let us look into. What is a constructor? It is a function. Constructor functions have some special characteristics. What are they? Let us see. First characteristic is, as I already mentioned, all the constructors must be declared in the public section. You cannot declare any constructor in a private section. Second characteristic is, you need not invoke, as I mentioned, x dot get data. Get data is a member function which you may have to invoke separately. But here, whenever it is a constructor, you need not invoke that constructor. The constructor will be automatically invoked when an object is created. Then they do not have return types, not even void, and therefore they cannot return any values. This is once again a very, very important point. Normally, when we define a member function or when we define functions, we will be having a concept or we will be having an opportunity to return a value. It could be an integer value, it could be a real value, it could be even an object also, depending upon the nature of the member function. But in case of constructor, there is no return value, not even a void. So it's very clear that constructor cannot return any values. At the same time, the constructors cannot be inherited. You cannot take the constructor of some other class. So you cannot derive a class with the constructor whatever is defined in the base class. So constructors cannot be inherited. So constructors can have a void as well as they can have an argument also. So constructors cannot be virtual. So we cannot refer to this at their addresses. So an object with a constructor cannot be used as a member of a union. So an object, whatever we get, it cannot be member of the union. So they make implicit calls to the operators new and delete when memory allocation is required. So these are the special characteristics of the constructor. So an example is given over here. So we define a class called counter. So this example will clearly explain how a constructor is used to initialize and how are we getting the member functions role in this program. So now let's look into the class called counter. So there is a class called counter with the one attribute, that is a, which is of type integer declared under private. So a is an integer which is declared under private. So under public we have both declared as well as defined a constructor. See, this is a constructor. Why do we call it a constructor? Because it's a member function having the name of the class itself. That's why it's called a constructor. So here the purpose of the constructor is to initialize the value a to 0. That means whenever you are creating an object of type counter, automatically its attribute, which is called a, will be initialized to 0. And we have two more member functions. One is called increment count, which will increment the value of a, and another one is get count, which is having a return value, that is it returns the value of a. So altogether, this is a class containing one constructor, one member, two member functions, which are declared as well as defined inside the class itself. So the class completes here. So now moving on to the main program, the main function. See here, I have declared two objects. One is C1 and another one is C2. So there are two objects which are declared as well as defined to be 0 whenever it is created, because counter is a class which contains a constructor which initializes the value a to be 0. That means the moment C1 and C2 are created, C1 dot A becomes 0 as well as C2 dot A also becomes 0. So because of the constructor. Now C1 dot get count. So what do you mean by get count? So the value of A will be displayed. Currently the value of A, because of the constructor, it is 0. C1 dot A is also 0. C2 dot A is also 0 because both have initialized its attribute a to 0. So whenever you get a count of a, so it becomes 0. Now use C1 dot increment count. When you increment count, this member function will be executed. So a becomes a plus plus. That means one increment will be taken to a. So even C2 dot increment count, here also this particular member function will work. So now C2 also will be incremented. C2 dot a also will be incremented to 1. So here C1 dot a was 0 because of the constructor. C2 dot a is also 0 because of the constructor. But by executing the member function here. So c1.a becomes the 1, c2.a also becomes 1. So you can make a note here. Even though constructor is a member function, we are not calling it anywhere. But when it comes to the other member functions, see here I'm calling int count. What is int count? It's a member function. I'm calling it. So get count is another member function. So whenever you declare a member function have to be called in the main function. But constructors need not be called. Constructors automatically initialize the value to 0 whenever they are created. Now, let us look into the different types of constructors. Now, the constructors are divided into three basic types, namely default constructor, parameterized constructor, and copy constructor. Now, what do you mean by a default constructor? A default constructor is that constructor which accepts no parameters. There is no parameter. So the example given over here, say counter is a constructor. There is no parameter. So the moment you declare C1 and C2, you are not passing any argument. So ultimately they will be initialized to 0. So this type of constructor is what is called default constructor. It's a classic example for the default constructor is the one which we have seen currently now. So if no such constructor is defined, then the compiler supplies a default constructor. Therefore, a statement A invokes the default constructor of the compiler to create the object A. So whenever there is no parameter sent, so that is called a default constructor. Now, I'll take another example where I define a class called X with the two variables. Let us say A and B, which are of type integer under private, and now under public I have once again a constructor. This is also a default constructor which assigns a value 10 and 20, 10 to A, 20 to B, and we have a member function to display the value of A as well as display the value of B. So now in the main function I call object 1 and object 2. So object 1 and object 2 are the objects of class X, and X has a constructor, and this is what is called a default constructor. So that means whenever object 1 is created, it will have object 1 dot A to be 0, object 1 dot B to be 10. Sorry, object 1 dot A is 10 and object 1 dot B becomes 20 because the constructor loads a value 10 to A and 20 to B. Similarly, object 2 also it is initialized to a value object 2 dot A to be 10, object 2 dot B to be 20. So whenever we display these two contents, our output looks something like this: 10, 20, 10, 20, because both the objects object 1 and object 2 are using a default constructor with the same value. So one point to note here is that whenever you have a default constructor, you can have any number of objects created of that particular class, but all the objects will be initialized to the same value, whatever we have seen or we have discussed here. Now, let's go to another type of constructor, that is parameterized constructors. So let's see what is meant by a parameterized constructor. It is a constructor with one or more parameters passed from the main to the constructor is called parameterized constructor. Now, why do we need parameterized constructor? So the major advantage of parameterized constructor is to initialize the different objects with the different values. So the drawback, whatever we see over here, object 1 as well as object 2 are initialized to same value. Object 1 dot A is become 10, object 1 dot B became 20, object 2 dot A became 10, object 2 dot B became 20. So same value. If I declare one more, so let us say object 3, object 3 dot A also becomes 10, object 3 dot B also becomes 20. That means a common value will be shared to all the objects. But in case of parameterized constructor, it's possible to initialize each object with the different values. Let's see how is it possible. So the structure of a parameterized constructor is something like this. So class, here we have defined a class, an integer with the two attributes m and n. So under public, we declare a parameterized constructor. Please make a note the difference between this constructor and this constructor. See here, this is a constructor which does not have any parameter, but when it comes to this constructor, it has a parameter. That's the reason why it is called a parameterized constructor. So now here it will take the value from the main function, and then the particular value will be initialized to the attributes. So m will take x value, n will take y value. So that's the reason why it is called a parameterized constructor. We will see how does it take the value, right? So here, for example, if I mention integer 1, right? Integer of 0, 100. So what do you mean by int 1, int 1 of 0, 100? What do you mean by this? So you are passing a parameter called 0 and 100 here. So now int 1 dot m is 0, int 1 dot n is 100. So we are supplying the parameters 0 and 100 from the main function to this particular constructor, so that I can have any number of objects with the different values which are initialized. So this is what is called the parameterized constructors. So here, uh, the parameterized constructors can be used by means of two ways. One, we can call the constructor explicitly, or we can call the constructor implicitly. Now, how we are calling the constructor explicitly and how we are calling the constructor implicitly, let us see. See, for example, if I use integer int1, what is integer? It is a class. Int1 is an object. Now I am explicitly loading the value int1.m to 0, int1.n to 100 by calling the constructor here, integer 0, 100. So integer 0, 100. So m becomes 0, n, 100. So I am explicitly calling that constructor, and I am loading the value to an object called int1. But here, just look at here, I am straight away declaring an object called int1 of class integer by passing the arguments 0, 100. So this and this are functionally the same, but here explicitly we are calling the constructor, but here constructor is not called directly. We define an object with the parameters. So 0 and 100 implicitly will be loaded to the attributes by calling a constructor. So this is the implicit method of calling a constructor. This is the explicit method of calling the constructor by defining an object, and then which is equal to calling a constructor by passing the parameter. Here we define an object along with the parameters to be sent to a object. Right here, there's a program which explains how a parameterized constructor is working. So I have called a class called integer. There are two attributes, and I am calling a constructor, just declaring a constructor. This is a display. So I'm using a constructor with the parameters which I'm passing to m and n value. But in in when it comes to here, see here, the concept which I just now explained is explained here. Here I'm creating an object called int1 by passing the arguments implicitly, but here I'm creating an object called int2 by passing the arguments explicitly. So this is a constructor which is explicitly called, here the constructor which is implicitly called. So it's very, see, one concept which I mentioned in the beginning, that is, I can declare different objects with the different values through parameterized constructor. I have proven over here. See, int1 is declared with the value int1.m to be 0, int1.n to be 100. Whereas int2 is a constructor, sorry, int2 is an object which has a value int2.m to be 25 and int2.n to be 75. See, int1 is initialized to different value, int2 is also initialized to different value, even though they are belonging to a same class with the same constructor working, but it's because of the parameterized constructor you can have different values to the objects. So now there is another method. A constructor can also be defined as an inline function. Let's see how does it work. So here we have defined a class called integer with int m and n. Here under public we are calling inline constructor. This is what is called an inline constructor, wherein I'm declaring as well as defining, and then I'm using it. So the example, whatever we saw over here, is not inline function. It is defined outside, but you can also do it inline also. So this is another method of calling constructor inline. So this is what is called inline constructor. The parameters of the constructor can be of any type except that of the class to which it belongs to. Now, let us go to the third type of constructor, which is called copy constructor. So let's see what is the meaning of a copy constructor. The meaning of a copy constructor is it is a constructor which creates an object by copying the variables from another object, similar object. So copy constructor is a constructor which creates an object by copying the variables from another object. So that's why here in this case we are uh, mentioning the purpose of this constructor. For example, just look at here. I'm declaring a constructor called I1. Then I'm declaring another constructor which is called I2, which takes the values from I1. Here I1 is an object. So I2 is sharing the details or the data from I1. So that's why this is called a copy constructor. Okay. So now here, so this is another method wherein I can call integer I2 is equal to I1. This is explicitly. So the purpose of initializing through a copy constructor is known as a copy initialization. So here I2 is equal to I1 is not a constructor. It doesn't invoke any constructor. It assigns a value. But I2 of I1, the one which whatever see over here, this is actually an example for a copy constructor. So here a beautiful example is given. ID is an attribute which is defined under integer. So defined under integer. Now I have, see, 1 and 2 and 3. There are three type of constructors which are mentioned. Default constructor, parameterized constructor, copy constructor. That means constructor overloading is also possible. I'm using three constructors here. One is default constructor, and there is a parameterized constructor wherein I take an argument and then I will pass it on to the ID, the attribute. Then here I will take an object itself. The object dot ID is copied to id. So this is a copy constructor. So here example explains here how does it work. So here code a of 100. Code a. What is code? Code is a class. A is an object of 100. That means which constructor will work among these three? So A of 100 is there. So that means there is a parameter which is taken. So ultimately, this particular constructor will work because 100 is taken as a parameter and A dot ID becomes 100. So A dot ID becomes 100. So this particular object is initialized to 100 through parameterized constructor. Now what is code B? Code B is a constructor or B is an object which passes a object as a parameter. It passes an object as a parameter. That means copy constructor will work here. See the difference you can observe. Here I am supplying an integer value. That's why a this parameterized constructor will work. But when it comes to here, I am supplying an object itself. So in this case, this particular constructor will work. So wherein the ID, that means b dot id, b dot id will be equal to x. What is x here? X is a dot id. That means b dot id is a copied content of a dot id. So here code C is equal to A, right? Code C is equal to A. So there is another constructor, there is another object called C, which is assigned a value A, which is also called a copy constructor. But when it comes to here, an object D is created. So by taking default argument, object D is created. D is assigned a value A. So now it's very clear. A uses a parameterized constructor to initialize its value. B uses a copy constructor to initialize its value. C also uses a copy constructor to initialize its value. D is just initialized. It doesn't use, it uses a default constructor, right? It uses a default constructor. Here it's just assigned, but no copy constructor is used. A, the value of D is nothing but A, just an assignment. So no constructor gets used here in this case. So here that's the reason. It uses all sorts of constructors. This is what is called multiple constructors in a class. So this is a classic example for multiple constructors. You define a default constructor, you define a parameterized constructor, you define an copy constructor. So all these things put together in a single class is what is called multiple constructors. So that is what is explained here about a multiple constructor. Here you can just make a note. I've defined a class called integer, default constructor, parameterized constructor, and copy constructor. So there are three constructors which are defined inside the class called integer. So I may use it anywhere. So I've defined it, I've used it, then I can use it a friend also. So I can use a friend also. So I can use friend, complex sum, complex complex. This is an example for complex number addition. So here I use the multiple constructors for my purpose. So whenever you declare a complex number, normally complex number has got two values, real value and imaginary value. X is what is called real value, Y is called imaginary value. Now I'm having a default constructor which no definition. Then I have a complex with the float A. See, there are two parameterized constructor, two different parameterized constructors. One with only one argument, another with the two different arguments, real value as well as imaginary value. So here there is only one value which is shared among real as well as imaginary. But here you have a different value for real and different value for imaginary. So now I use friend function to add the two complex numbers, as well as I use a friend function to display the complex number after addition. So here complex sum, so there is a mistake here, bracket is not this, complex sum complex C1 and complex C2. So I'm using a friend function. That's the reason I use sum. So I declare a temporary variable, temporary argument called C3. C3 dot x will be C1 dot x plus C2 dot x, and C3 dot y will be C1 dot y plus C2 dot y. So real numbers are of the two complex numbers are added and stored here. Imaginary numbers of the both the complex numbers C1 and C2 are added and stored in the C3. Now C3 contains the sum of the two complex numbers after addition. I'm returning the C3 to main function, and this is to display the value of the complex number. So let me come to the main program. So here I'm using a complex A. A is an object with 2.7 and 3.5. So 2.57 is a real value, 3.5 is an imaginary value. So here this particular constructor will work with the 2.7 being x, 3.5 being y, because there are two arguments. But when it comes to B, B passes only one argument. So here, this particular constructor will work. So now B dot x becomes 1.6, B dot y also becomes 1.6 because it is passing only one argument, x is equal to y is equal to a. So here B a becomes 2.7 plus 3.5 j, B becomes 1.6 plus 1.6 j. Now, when it comes to complex C, it uses a default constructor with the no value. C will be created. Now, I am using a friend function. C is equal to sum of A and B. Now, sum is a friend function which takes a value 2.7 and 3.5, B value 1.6 and 1.6. So here 2.7 and 3.5, 1.6 and 1.6. So 2.7 plus 1.6 will be the real value. 3.5 plus 1.6 being the imaginary value will be added, and the answer will be stored at C. And then I'm displaying A, B, and C as separate values. So this is how the output comes after executing this program. So next point is constructors with the default arguments. So what do you mean by constructors with the default argument? See, I'll take you back to this example. For example, this. See, complex float real and float imaginary. How many arguments are there here? There are two arguments. Separate arguments, one for real value, one for imaginary value, with the specific values which are taken. So A is supplying 2.7 and 3.5. But there is also a possibility that you can create another argument as 0. So the meaning of this is you are defining a constructor with the real value as a real value. Imaginary value is somebody gives, you take that imaginary value. If there is no imaginary value means you keep it as 0. That is the meaning of the default argument. How does it work? Let me explain you. See, I am having a object called C with the two arguments 2.0 and 3.0. So when I have this, real value will be 2.0, imaginary value also will be 3.0. That is a meaning because I have an argument here in this particular object. But when it comes to here, I need two arguments actually, but I don't have two arguments, I have only one argument. So under this condition, real value will be 5.0. Since there is no imaginary value, automatically imaginary value will be set to 0. That is the meaning of default arguments. So if the specifically you mention the value for the arguments, it will take the value whatever you send from the main program. But if you don't have a specific argument, then whatever the constructor explains or mentions the default value will be treated for the account. So here is an example for the bank account, how you are going to execute this. See here, there is a class called fixed deposit. Yes. created with the long integer as a principal amount, integer as years, float as rate, float as R value. Then there are three constructors defined. One is fixed deposit without any arguments. Another is a fixed deposit with the default argument. See, you can see a default argument. And third one, fixed deposit with the argument. So parameterized. Default constructor, parameterized constructor with the default argument, and another one is a parameterized constructor. Then you have got one friend function, that member function called display. Now let's see here. You are taking the arguments, you are calculating it. Here also you are taking the argument, you are calculating it, and then when it comes to main, I am creating FD1, FD2, and FD3. So FD1, FD2, FD3, these are the three objects which are created by running the default constructor, because there is no argument which is sent. So by using a default argument, FD1, FD2, and FD3 will be created. Now I am defining other variables here. I'm taking principal value, years, and rate of interest. Now let us look at here. FD1 is equal to fixed deposit of P, Y, R. Let us look into the constructor which is getting used. Which constructor is getting used? Because we have got multiple constructors here. FD1 is equal to fixed deposit of P, Y, R, where P is a long int, Y is an int, R is also an int. So now it is this particular constructor which will work. Long int, int, int. So this particular constructor will work because the parameter is suitable to this particular consequence. But remember, here it is explicitly defined. So explicit definition of a constructor. Now let us look into here. P, Y, R. Now P is a long int, Y is once again int, R is a float here. So FD2 makes use of this particular constructor. See, matching should be perfect. Even though there are three arguments here, but the type of arguments are different. Here it is int R, here it is float R. So FD1 will use this particular constructor to execute. FD2 will use this particular constructor to execute. So FD3 is fixed deposit of P, Y. So where this particular constructor will be used, P, Y. So R is taken as 0.12 because default constructor. So FD1 will be displayed, FD2 also will be displayed, and FD3 also will be displayed. So the logic of this program is these three objects are created by means of a default constructor. This makes use of the third one. This makes use of second one. This makes use of the default argument, constructor with the default argument, and they will be used. So here the example gives the uses of different types of constructors. So now let us look into the concept of distructors. So what do you mean by distructors? A destructor, as the name says, is used to destroy the object. Very simple. Constructor is used to initialize a constructor. Destructor is used to destroy the constructor. Now, how are you going to define a destructor? We can define a destructor by means of a tilde character over the constructor. That's all. See, take this example, matrix, tilde matrix. This is how we define the destructor here. So same way, another example is given. We create a class called book with all the properties, the attributes. Then here I use a constructor with the value which I show display here. Then I use the values which are loaded to the attributes. Then I use a display function to display them. Then I use a destructor here just to destroy it. So now it will be displayed, and later on the content will be destroyed. The object will be destroyed by means of the destructor. So with that, we have completed the concept of constructors as well as destructors. Have a good day. Thank you.